Lesson 10-4, Changing Dimensions. Our objective here is to learn how to make a model to explore how area and perimeter are affected by changes in the dimensions of a figure. And dimensions are just the measurements of an object or of an area. So here we have a couple of objects. Here's our larger rectangle, and the dimensions of this are 4 centimeters and 2 centimeters. And we have a smaller rectangle over here, and our dimensions of this are 2 centimeters and 1 centimeter. Now you might remember when we were looking at similar figures, and that similar figures have the same shape but not necessarily the same size. Well, this is something very similar when we're looking at changing dimensions. So here we have something, again, it's the same. These are similar figures. They have the same shape, but they're different sizes. And we want to compare how the perimeter and how their perimeters compare and how their areas compare. So let's first take a look at perimeter, and we'll take a look at the perimeter of the large rectangle first. And if we know that this is 2, then that means that this is 2 here. If we know this is 4, then this is 4, since it is a rectangle. And we could say that 4 plus 2 plus 2, and that all together is going to give us 8, 10, and 12 centimeters. So the perimeter of the large rectangle is 12 centimeters. We could also do this. We could also look at saying 2 times the length and the width. So we could say this as well, and we have 4 plus 2 is 6, and 6 times 2 is also 12. Either of those will work for the perimeter of this larger rectangle. So let's look at the perimeter of the smaller rectangle. Well, we know if this is 2 on top, this is 2. If this is 1 on the side, that's 1 on the other side. So we end up with 2 plus 2 plus 1 plus 1, 4, 5, and 6 centimeters. So how do these perimeters compare? Well, our perimeter for the large is 12, our perimeter for the small is 6. So I could say it's when we go from the 12 to the 6, it's like dividing the large perimeter by 2. So we could say that the perimeter of the small is the perimeter of the large divided by 2. That is how those perimeters compare. Now let's take a look at area. So let's take a look at the area of the large. Well, we know the area is length times width, or base times height. And so we have a length or a width of 4 and a height of 2. So we have 4 times 2, and that is going to give us 8 square centimeters. Well, our area of the small, again, length times width. Our width is 2, our length is 1. So 1 times 2, so our area of the small rectangle is 2 square centimeters. So let's take a look at how these two compare. From the large was 8 and the small was 2. We could think of that as dividing the area of the large rectangle by 4. So we could say the area of the small rectangle is the area of the large rectangle divided by 4. Now we could also say these in reverse. We could say that the perimeter of the large rectangle is the perimeter of the small multiplied by 2. Just as we could say that the area of the large is the area of the small rectangle multiplied by 4. These mean the same things, it just depends on which one you're starting with and you're comparing it to the other one.